Store community. This is Store co-creator Chris McCoy, and I'm here to give you the first ever demo of the Store protocol. Before we begin, what is Store? It's a new layer 1 staking protocol at the intersection of zero-fee block space and cloud space. We're the first project to credibly vertically integrate high-performance Web3 cloud computing with high-speed block space. Before I get into the presentation, here are the obligatory disclaimers. The information provided here is for general information purposes only. It's not a formal offer to sell or solicit an offer to buy any securities. While this information in this demonstration is believed to be accurate and reliable, Store, our agents, advisors, directors, officers, employees, shareholders, and more make no representations or warranties expressed or implied as to the accuracy of this information. And you can read the rest here. Back to our demo. So here's Store. As we've said in our latest investor update, we're now doing what we initially set out to do, which is producing blocks on our high-speed, zero-fee Store public blockchain. I'm going to demonstrate that today. I'm going to also show you Store Cloud, Store Governance, Store Monetary Policy, and walk you through what we believe is our first use case for Store computing resources, which is one-click, forever stored NFTs. So here is what we call Store Explorer. This is pulling from the Store Oracle. Everything you see here is built on Store Cloud. Nothing is on Amazon Web Services. Nothing is on Microsoft Azure or any public cloud. It's all on trust minimized and what will be governed Store Cloud. We're the first protocol to build on this type of infrastructure. Let me demonstrate here what 1,000 transactions look like. Now, we're still testing on a relatively small network of nodes, so we're not benchmarking transactions per second, although we do have high confidence that Store chain will be very high speed. And as we get through the next phase of our build, you'll see us start to publish TPS numbers. With that said, we're going to send 1,000 transactions here into the Store chain. Let's have them both be two store each. Okay, we're sending the transactions. Here you can see the transactions are now being built. We're confirming. They've now finalized. We've produced blocks. We've produced transaction pages. Here you can see transaction detail pages, where all the metadata that makes up the Store transaction is displayed, from transaction size to nonces to signatures to transaction IDs to block IDs. What we're not showing yet is dynamic proof of stake, which is our economic algorithm to stabilize network security in a state-dependent way. You can think of it almost as like Uber surge pricing, but for network security. That is part of our next build. Where you can see transaction detail pages coming from Store chain APIs and block detail pages coming from Store chain APIs. The data itself, which makes Store unique, is forever stored on Store Cloud, which we'll show you in a second. It's governed by Store Governance, which now we're in first governance, getting ready to upgrade to Store second governance, and it's incentivized by Store Monetary Policy. Store Cloud itself is operational. It's in 6 data centers, and it can scale out as demanded. What makes Store unique is that all computing resources are actually priced in the Store token. We call bits micro units of Store. One Store token equals 100 million bits. And on the protocol, 1 byte of perpetual storage, or storage that will exist forever if Store governance stays solvent forever. 1 byte of data costs 2,300 bits and stabilizes algorithmically. This is a very big breakthrough in research and development for us. This enables not just perpetual file storage, but blockchain history storage as well, all in the same monetary system and the same infrastructure. Again, we're the first protocol in the world to do this. As you can see here, there are no revenues yet. There's no total value locked in Store Cloud, but there will be, and we'll communicate that in real time in the future. We're in 6 data centers now, as you can see here. These data centers, you can see the compute that's available, the RAM, the storage, and based upon the value of store, we'll be able to demonstrate the actual value of that storage, both in dollars and in the store token itself. Take a quick look here. Back to transaction pages. So we have transaction detail pages, which has the history of transactions on the system. We have block detail pages. And one thing that we'll point out is that the burnt fee, part of our dynamic proof of stake algorithm, isn't live yet in our test environment, but essentially we estimate 70 to 80% of any fee-based transaction. That's a transaction where the demand to use the block space is greater than what the miners are willing to provide for just inflationary rewards only. 70 to 80% of that will be burnt. And not only will block space be burnt, but we'll show you in a second, cloud space will be burnt as well. Now we take a look at infrastructure. Because what Store does is different than what other smart contracting systems do, which they don't store history. They outsource it to third parties like Infra or Arweave or centralized nodes. And what ends up happening is leaders emerge in storing that data, building industry-leading APIs, and then the application ecosystem around those APIs grows, and essentially those storage providers become centralized providers for the blockchain economy. And the same form of centralization we see in Web 2, where you have data aggregation, whether it's Google, Facebook, Amazon, etc., is starting to happen in Web 3. And that's because protocols have failed to be creative enough and sophisticated enough in their economics to incentivize storage of blockchain history, and Store does that from the outset. It's much more like Bitcoin in that manner. But to compensate, Store nodes are bigger. So you can see here what Store compute requirements will look like for our block miners and our cloud miners. And what you can see here is the data will communicate in real time to help the world understand how performant the Store chain is, time to finality, latency, transactions per second capacity, database size, database copies, which 5 database copies are stored at all times. And we'll communicate what the estimated infrastructure costs for miners are in real time, which helps the system stabilize itself from an economics perspective. And from a consensus perspective, Store is built on our patented consensus mechanism called BlockFin BFT. It's the first commercially viable leaderless asynchronous high performance consensus mechanism in the world. Other systems have tried it. We won't say their names, but they're well known in the many billions of dollars of market value. And we're doing it today with a patent, which is really powerful. We'll communicate in real time things like what's the total value locked in the system, how much is staked, how much is committed, what that economic value is, security of the network, cost to 2/3 attack the system, the break-even cost to mint a store as it relates to the infrastructure costs. We pay a tremendous amount of attention to the computing economics, which we'll show you in a second here. The profit margins that miners are generating against their infrastructure costs, which is a major part of our competitive advantage to beat the industry, not just on performance and available computing resources, but also on economics. Dynamic proof of stake, as we discussed earlier, essentially says if the network is willing to take 20% of the circulating supply for security, but only say 18% is staked, and the maximum inflation rate's 1%, then the network's not going to actually issue 1%. It's going to issue less than 1% based on a curve. And this adjusts every quarter based upon the performance of auctions, which secure the system. We communicate capacity of Store cloud in real time. We communicate the cost of cloud space. So this is essentially the cost of store computing resources. Resources aren't just storage. It's no different than Amazon Web Services, where they have S2 and EC2. So compute and storage. We have CPU, we have RAM, we have perpetual storage. As we said earlier, 1 byte right now equals 2,300 bits. The cost per byte of data is pretty low in dollar terms. This will stabilize using a proprietary algorithm that we'll introduce here shortly. And again, all of this logic is powered by the Store Oracle, which is stored on Store Cloud and governed by Store Cloud. It's a small network today. Next phase of testing, we'll move into 100 nodes, and we'll start to produce block performance times. DDoS protection is a way in which we're able to rate limit how much traffic can come into our miners based upon the previous day's demand. And Surge essentially introduces fees when there's more demand to secure, to use the block space than there is available supply. This is almost like Uber surge pricing for block space itself. So these are the kind of economic and security systems that give Store its intelligence. Now, before we get into our first use case, let's take a look at governance, let's take a look at cloud, let's take a look at monetary policy. So we talked about cloud, so let's take a look at what that looks like in practice. So if I'm a winning miner of a Store auction, then I need to ratify my infrastructure. And what this means is I have costs. These costs I need to pay them before I have the ability to govern infrastructure and get paid to manage and support this infrastructure. You see here what the system requirements are, and these requirements can change in real time based upon the results of governance, based upon the needs of the network. This is how Store can horizontally scale as a global computing system. Everything from memory to compute to capacity to the type of class of instances. There's virtual machines that run, so Store Chain will actually run as a virtual machine in Store Cloud. You see the type of operators that are being supported by the cloud here. These are the services, so these are essentially showing you the governance application, which we'll show you in a second. The oracles, the APIs that drive intelligence into Store Cloud, into Store Chain, into the Store protocol itself. Store has the ability to support other nodes and ecosystems of their nodes, and that's up to governance in the future. But the key here is that Store isn't limited to earning fees off of block space. It will earn fees off of cloud resources. So it's expanding the possibility of what a protocol can incentivize and actually generate revenue around. And so theoretically, this workload here would cost miners $160,000 Store, $12,000 a year. Miners who are 2/3 trusted and in position to compete in the Store network, they pay for their infrastructure. And when they pay, their infrastructure is, they're 2/3 trusted now, and they manage the Store Cloud. Back to Store itself. So look at governance. So governance is effectively what we call a democracy. It's checks and balances driven. Where we're headed with it is you have a Store Foundation that's elected, and it is what issues the asset and governs the rules of the protocol. It crafts ballots. The voters and miners who stake and compete in auctions become 2/3 trusted, have Byzantine fault tolerant ID. They can actually overrule the foundation. So practice, what this looks like is the foundation crafts a ballot, the voters vote, the foundation can overrule their vote. The voters can actually then overrule the foundation. At that point, that's law within the network, and the foundation follows those rules. So it's the first credible attempt at checks and balances. As you can see here, these are the data structures that make up Store governance, everything from what version of the governance it is, what the security model for governance, the identity model, protocol level governance, market level governance, what the first ballot majority, second ballot majority is, who the second voting chamber is, who can overrule. And so as Store governance gains legitimacy, other systems can inherit our APIs and actually bring Store governance into their computing environment. Today we have 82 voters in our first governance, where it's one $10,000 one vote. We've executed 5 ballots so far with nearly 77% approval. It represents 73+% of the actual supply in the network, which is really cool. Right now it costs about $256,000 Store. It's priced at 3.9 cents in order to have a vote, one $10,000. This will be auction based in the future. And then auctions will drive the, we'll call it value of the security of the network. And you can see here, we're starting to chart all of our votes. Now, monetary policy itself is a significant part of STORE. We have spent a tremendous amount of resources on trying to design a system that's equitable, it's fair, and it is long-term in nature. And we're working with some of the best institutions in the world to facilitate monetary policy. Anchorage for lending and custody, BitGo for custody. You can almost think of this as our banking infrastructure. We work with several OTC partners. We're in conversations with the big four accounting firm about facilitating our entire treasury system. We have talented lawyers helping us be very specific. But what you can see here is as STORE launches, we'll continue to communicate the kind of economics of the system and the monetary system in real time in a very auditable and public way. Inflation will range between 1% to 2%, and when you look at the kind of real yield that miners and holders potentially earn through STORE, what you see is a system that rivals the leading systems in the world. Now, let's take a look at governance tooling. So we're building world-class tooling to manage checks and balances governance. So if you're a staked miner or voter, this is what you'll see. Very crisp ballots with significant amount of metadata that help you understand what you're voting on, support files, links. It's all signature based, so you log in with your wallet, and from there you have the right to vote. And you see first ballots, a second ballot to overrule, ballots that have ended, and then transaction history. So as you earn STORE rewards, we're building governance tooling so that you can track what rewards you have earned. This will help with taxes. On the foundation side, this is setting up ballots. Everything from infrastructure to economics to monetary policy to leadership can be set up with these templates. One of the defining features of STORE is the ability to actually upgrade computing infrastructure. And as you can see here, this is how it's done. Other protocols, layer ones, struggle with this. When miners get flooded with traffic, they tend to shut down. Blockchain has to restart. With STORE is because we have such a crisp understanding of the economics of computing, the ability to upgrade infrastructure relatively quickly. We should be in a strong position to not have that happen. So this is the foundation side, and this is the foundation issuing rewards. Here. Now let's take a look at first use case. So let's say STORE Chain is still very much a research project. We have quite a lot of work to do to get it through security audits and get our clients built, but we're making daily progress. Let's demonstrate the power of STORE Chain in our first use case, which is one-click NFTs. So I'm going to show you first is storing on STORE forever and minting the NFT on the STORE Chain. And then I'll walk you through our production first use case, which is actually storing on STORE forever and minting on Ethereum, which is actually live now in a test network. So here's STORE forever. So let's say I want to store an asset, whether it's a video file, an image, could be a whole Hollywood movie, could be 10 gigabytes, we could have it be 100 gigabytes, doesn't matter. Key is this is stored in STORE Cloud. The issuer is paying for the storage of this asset here. They're paying cloud space fees, as you can see here. These fees are 1 byte of data is 2,300 bits of STORE. Every byte of data, every character, test title for my NFT is a byte. Test description. So I'm starting to add metadata to this asset, to this NFT. I can mint more than one. I can mint 5 if I'd like. I can establish a mint price. Again, this is all on chain. We're working on really interesting logic that ties the economics of computing to marketing incentives and other incentives for NFTs. But in this scenario, I can add the store icon in exchange for a discount on my cloud space fees. I can add the limited supply number. So this acts as a bit of a Trojan horse for marketing and branding for the store brand at global scale. And we're big believers that the emergent winners in these systems are going to be the biggest brands. And as you followed us historically, we stayed pretty under the radar. From marketing PR perspective, we have quite ambitious objectives on the marketing front as the protocol comes to life. We're doing things with our smart contracts design that enable new forms of, let's call it, distribution for NFTs. So you can see here, as the issuer, I can add, I could say 10,000 store, pay for distribution. So when users of the application layer share my asset, I can pay them in the store tokens. We call this cost per 1,000 followers, CPF. It's almost like CPM, but instead of for ads, it's for social distribution. I can do this on Twitter. And if let's say theoretically this is a video is highly likely to be pay-per-view in the world of NFTs and the tradable internet. And I theoretically can take a percentage of my video revenue, my pay-per-view revenue, and I can actually fund that, perpetually fund my distribution fund. So constantly, consistently, this has revenues to be funded. Royalties, massive part of content, especially more valuable content like music and movies. The ability to not only pay royalties on each sell, but each royalties when there's pay-per-views. So if there's a video and it's 5 store, I can share revenues programmatically through smart contracts to the various owners and those who are earning the royalties. And if I'm saying producer, and I'm going to add my store address here, a demonstration address. But once I get enough characters in there, it will approve me. Okay, I can say I'm going to earn 5%. And as you see here, this is costing cloud space fees. Every time I add data, it's not just adding to the smart contract, it's actually adding to the cloud, and I'm paying for that. And I can add any number of folks on the chain. So here, pay-per-view is going to play a role in content and NFTs. We're designing for it. I can place the NFT behind a paywall and charge a store to watch this. I can ensure that the distribution funds continually loaded up through these revenues. And finally, intellectual property rights. So this is an important part of kind of major issue in the world of NFTs today. But as you can see here, I can assign Creative Commons universal ownership. I can give non-exclusive rights with specific rules across revenue limitations, formats, time periods. I give exclusive commercial rights. I can issue for personal use only. So let's say I've built this microeconomy around my NFT now. Now let's mint this onto the store chain. And what you're going to see here is this asset is going to be embedded in line with transaction detail page. So you can see here all data about this specific NFT. So we're the first protocol to integrate file storage in with block space. So you get nonces and signatures, transaction IDs, block IDs. These become the individual smart contract IDs for the specific logic that we gave the economy around this content. We're actually building and writing this now. Really exciting research and development. Our R&D team is just on fire right now. It's exciting. And you see here, this asset has an asset ID page on Store Cloud. So this is the page where it's perpetually stored. So you're able to see what blockchain it's stored on, in this case store, what cloud it's on, it's store, and the metadata that makes up the intersection of block space and cloud space for this asset. And within Store Explorer, we're working on an NFT marketplace to give store NFTs the ability to come to life. Now let's take a look at our first use case, which it won't be NFTs on store chain because store chain will take more time from an R&D perspective. We're excited about our progress here. We're treating this very conservatively. The responsibility to bring new block space into the world is probably the most sophisticated thing I'll ever personally work on, and we want to be really correct about our assumptions and the ability to secure it and scale it before we go to market. But we do think when we do, we'll be able to compete with the leading layer ones, if not beat them. And we're planning to beat them. Let's take a look at what we call cross-cloud compatibility. So let's say I want to store an asset forever, but I want to mint the NFT itself on Ethereum block space. So what you're going to see here is everything you just saw, but test 1, 2, 3, description 1, 2, 3. But instead of store cloud space, block space, it's actually Ethereum cloud block space. So there's gas fees. So I'm not connected yet to the Ethereum chain, but you're going to see here, I try to mint, it's going to ask me to connect. So I'm going to connect my MetaMask. So this is in production here in our test environment, but we're interacting with the Ethereum chain now. So squirrely. So let's confirm. So we're going to mint this NFT onto the Ethereum chain. It'll take a second. So we're minted. Now the transaction is being finalized on Ethereum test network. The token contract is being minted on Ethereum test network. And what you'll see is the asset ID will be perpetually stored on Store Cloud. You paid those cloud fees. And now the reference into Ethereum block space will show up here in a second. And then what we're doing in Ethereum block space is writing in the asset ID into the token contract. So they cross-reference each other, essentially. So we like to think of this as almost like Instagram for NFTs. One click, one token, immutable NFT storage, and NFT issuance. So while we're waiting, you can see that we're now connected into the Ethereum chain. We can connect into Polygon Optimism. Our next build is to introduce our test token to essentially be a proxy token for Store, so we can facilitate cloud space fees all in the same environment. You can see here is Ethereum data now has written in the blockchain that this asset's on is Ethereum, the cloud is Store. We have transaction ID pages. This is the Gorley testnet transaction for this specific NFT. We have contract ID pages. We have block ID pages. Yeah. So that's it. So more to come. We're making very steady daily progress. Good things come to those who wait, and persistence matters a lot in these challenging technical endeavors. We see the experiment we're undertaking is one in which we're attempting to bring democracy, democratic governance to computing resources, and eventually even to computers. And Store is a protocol that's incentivizing both block space and cloud space. We think that ultimately we're competing not just with Ethereum and Solana and Sui and these other layer ones, but ultimately with Amazon Web Services. And we're vertically integrating these computing resources into just a single system. And we're the first to do that. And we're working hard to legitimize our governance system. And as Store Chain comes online, we'll migrate off of an ERC20 asset into the Store native asset. So behind the scenes, we're working on staking software, we're working on wallet software, we're working on elliptic curve design, etc. There's a lot of exciting research at Store. Appreciate your support, and our team has tremendous resolve. We can win, and not only win, but we can have an impact on the future in a way that helps the tradable internet, not the centralized ad-supported internet, the internet where every asset is represented by a private key. It's tradable. It can generate revenues. It can generate fees. Generate revenue sharing. That internet is more equitable than the one we're in today, and that's the world we're building. Thank you.